Okay, in this video, we want to find the general equation for this. In order to do that, we need to get eigenvalues and eigenvectors. And so we first say 3 minus r, negative 1 remains the same, and 6 remains the same. This diagonal will always remain the same. And then we have negative 2 minus r. So essentially this diagonal, we just say minus r is equal to 0. And so we multiply this by this, and we would get, so negative 2 times 3 is negative 6. Negative r times 3 is negative 3r. Then negative 2 times negative r would be plus 2r. Negative r times negative r would be plus r squared. Then we have minus, parentheses, minus 1 times 6, so plus 6 is equal to 0. And next we will group this, and so we can say r squared, and then we have negative 3r plus 2r, so minus r. Negative 6 plus 6 is 0, so is equal to 0. We can factor out an r, so we can say r times r minus 1 is equal to 0. And so our eigenvalues will be r is equal to 0 or r is equal to 1. And so with these eigenvalues, the next thing that we're going to do is get eigenvectors. So we say for r is equal to 0, so we're plugging in 0 for r, we would get 3, negative 1, 6, minus 2. The same thing, because we're not adding or subtracting any r, because it's r is equal to 0. And so the next thing that we're going to want to do is try to cancel out one of these terms, like one of these rows. And we can cancel out this one right here. We can cancel out r2 if we say that r2 is equal to 3r2 plus r1. So we're multiplying this row by 3, and we would get negative 3, negative 6, and then we're adding 3 to it, adding 6 to it. And so we would get 0, 0. And to make our lives even easier, we can multiply this row by 1/3, and we would get 1, 2. And so we will therefore say that v1 is equal to minus, or the opposite of this, of 2v2. And so if we can therefore say v1 is equal to minus 2v2. And so if v1 is, say, negative 2, that means v2 would be 1. Because if we plug in 1 for v2, we get negative 2. And so v1 is negative 2. And so this is our eigenvector for r is equal to 0. And the next thing that we're going to do is do the eigenvalue of r is equal to 1. And so we plug in 1 here, we plug in 1, and we get 3 minus 1 is 2, negative 1 remains the same, 6 remains the same, negative 2 minus 1 would be negative 3, and next we will do the row reduced echelon form, so we will try to cancel out one of these terms. If we multiply this row by 2, we would get negative 2, negative 6, and then if we add r1, this row, we would get 0, 0. And to make our lives easier, if we multiply this row by 1/2, we would get 1, 3. And so we can conclude that v1 is equal to minus parentheses 3v2. It's always the opposite. And so we can therefore say v1 is equal to minus 3v2. And if v1 is, let's say, negative 3, that means v2 would be 1. Or if v2 is just 1, then we have negative 3 times 1, so negative 3 for v1. And this is our eigenvector for r is equal to 1. And now we want to get the general solution. So we can say the general solution will be c1 e raised to 0t. This is because the eigenvalue was 0, and our eigenvector was negative 2, 1. So negative 2, 1 plus c2e raised to 1t, because our eigenvalue was 1, and our eigenvector was negative 3, 1. And we know that e raised to 0 is 1, so we can just say c1, the eigenvector was negative 2, 1, plus c2 e raised to t, eigenvector was negative 3, 1. And this right here is our general solution. And that's all we need to do.